when you think about the human body, the cardiovascular system is it's this absolute miracle of plumbing, right?
Oh, for sure. It just works.
Exactly. It's constant, it's flowing, and it's almost entirely invisible to us while it does its job. But if there's a clot, like a sudden blockage in a major artery, the whole system goes into crisis.
Yeah, the body literally has a heart attack. The flow of oxygen just stops.
Right.
And suddenly every single organ is affected. I mean, your brain, your muscles, everything just grinds to a halt because that central infrastructure failed.
So today we are zooming in on the cardiovascular system of the global economy, specifically the Port of Los Angeles.
Which is a massive topic.
It is. Our mission for this deep dive is to explore this invisible, high-stakes nervous system of the global supply chain. And we're pulling from a really fascinating stack of sources for you today.
We've got the port's official 2026 to 2030 strategic plan, right?
Yeah, and some highly detailed technology requests for proposals, plus a recent UCLA Labor Center study, and even some executive keynote speeches.
It's a staggering amount of information, but it paints a picture of an environment undergoing this radical, almost science fiction level transformation.
Just to keep that economic blood flowing.
Mm-hmm.
And to really grasp the stakes here, we have to look at a recent keynote address from the port's executive director.
That's Gene Soroka, right?
Yes, Gene Soroka. He laid out just how colossal the San Pedro Bay port complex really is. I mean, it is the 10th busiest port globally.
Which is wild to think about.
Right. It handles over 30% of all U.S. domestic containerized imports.
Mm-hmm.
And in 2025 alone, they moved 10.2 million container units.
Just try to imagine that. 10 million of those 40-foot steel boxes.
It's hard to even picture. But that sheer volume is why that cardiovascular metaphor works so well. Because, a few years ago, the COVID-19 pandemic acted as the ultimate stress test.
Oh, absolutely. We all felt that.
Yeah. It exposed just how incredibly fragile the global supply chain really is when a clot forms. A total economic heart attack.
For sure. But there was a specific detail from Soroka's speech that completely changed how I view this infrastructure.
Oh, about the humanitarian aid.
Yeah. During the height of that crisis, the port actually stepped in as a humanitarian force. They established something called LVLA.
Logistics Victory Los Angeles, right?
Exactly. They partnered with Honeywell to produce 24 million N95 masks, and they used their logistical muscle to allocate them to local hospitals and nursing facilities at exactly cost.
Wait, really? No markup at all?
No markup whatsoever. It was 79 cents a unit, which is just a brilliant example of utilizing existing logistics infrastructure for immediate local relief.
Wow, that's incredible. But I imagine operating at that level of precision during a crisis, well, it must have highlighted some glaring vulnerabilities too.
Oh, big time. Managing emergency humanitarian aid while simultaneously trying to unsnarl the daily flow of 10 million commercial containers.
Right.
It requires a level of coordination that human beings simply cannot manage with clipboards and radios.
I'm trying to visualize this because, okay, we know the physical ships are immense. The cranes are these giant steel structures towering over the water.
Right.
But how does a port actually solve a physical traffic jam of multi-ton steel boxes using, invisible digital data?
Well, they had to fundamentally shift from what we call reactive logistics to predictive logistics.
I mean, what does that mean in practice?
So historically, a port basically operated like a parking lot. You wait for a ship to arrive, and then you figure out where to stack the boxes.
Oh, okay.
And then you just wait for trucks to show up to take them away. But to prevent future bottlenecks, they realized they needed to know exactly what is happening, where it's happening, and when it's going to happen.
Like way in advance.
Yeah, weeks before a ship even hits the horizon. They basically needed a unified digital brain.
Which introduces something from our sources called the Port Optimizer.
Yes, this is fascinating.
According to the research, this was co-created back in 2016 with GE Transportation. It pulls direct feeds from U.S. Customs data.
And today, 9 of the top 10 global ocean carriers actually use it.
That's huge adoption.
Yeah.
So it functions as this single secure portal for supply chain partners to get real-time tracking data. And they just got a significant injection of state funding to expand it, right?
Yeah, an $8 million grant. That came for the California Governor's Office of Business and Economic Development.
UBiz.
Right, UBiz. And this is actually part of a larger $27 million push to improve data functionality across California's entire port network.
Okay, so this grant is funding 3 specific upgrades. First, a universal truck appointment system that shares data with the neighboring port of Long Beach.
Which is such a big deal.
It really is. But it actually caught me off guard. You mean to tell me the two busiest ports in America, which physically border each other, didn't already share truck appointments?
They didn't. It's crazy. Trucking companies were logging into like multiple different fragmented systems just to pick up boxes that were sitting literally a few miles apart.
Oh man, what a headache.
Yeah. So the new universal system stops bottlenecks at the literal gate by creating one seamless schedule for the entire San Pedro Bay complex.
That makes so much sense.
Okay.
Now, the second upgrade is the CalPort's mobile app. This gives stakeholders the ability to track cargo status directly on their phones so they can anticipate disruptions.
Right. Getting the data into the hands of the people who need it.
But the third upgrade is what really stood out to me. It's called a Green Asset Score Gateway.
Oh, the Green Asset Score is a critical mechanism. It tracks near real-time carbon emissions from, well, everything. The rails, the trucks, the vessels, the port equipment.
So what do they do with that data?
Instead of stakeholders just looking at a dashboard and optimizing a route purely for speed or cost, they can now actively balance the cargo speed against its environmental impact.
That's amazing.
Right. So if a specific trucking route is highly congested and idling engines will spike emissions, the system just flags it.
And this brings real, tangible benefits. I mean, the tech stats in the sources regarding these optimizations are pretty striking.
Yeah, the numbers are wild.
By deploying AI predictive analytics, they've already reduced average truck dwell times by 12%. And they improved gate efficiency by 7%.
Which is exactly the kind of efficiency that prevents your holiday packages from being delayed.
Yeah, or stops the cost of your electronics from skyrocketing due to, supply chain bloat.
Exactly.
But this is also where the technology takes a turn into the surreal. Over at Pier 300, they introduced quantum computing.
Yes, specifically, they are using the Savant X HONE framework integrated with D-Wave systems.
Okay, I have to stop you there. I see D-Wave systems and Savant X in our research notes, and my eyes completely glaze over.
It sounds super intimidating, I know.
Quantum computing sounds like a buzzword from a sci-fi movie. I mean, how does a supercomputer utilizing quantum mechanics actually move a physical multi-ton steel box faster?
Well, it basically comes down to solving a mathematical nightmare known as combinatorial optimization.
Okay, break that down for me.
Imagine you have a terminal yard with thousands of containers. You have dozens of massive cranes that need to move them, and hundreds of trucks arriving at all different times to pick them up.
Sounds chaotic.
Very. Now, a standard classical computer calculates the best move for crane A, and then it calculates the best move for crane B. It operates in a linear fashion.
Right, it's just solving one problem at a time.
Exactly. But D-Wave builds physical quantum computers that use extreme cold and superconducting loops to tap into quantum mechanics.
Wow.
So instead of looking at one move at a time, quantum computing can instantly evaluate millions of possible combinations for all crane movements and all truck arrivals simultaneously.
That's hard to wrap my head around.
Think of it like trying to find the lowest point in a vast mountain range. A regular computer walks up and down every single peak and valley to find the lowest point.
Right, which takes forever.
Yeah. But a quantum computer basically floods the entire mountain range with water and instantly sees where the water settles.
Oh, that's a great analogy. So it evaluates the entire landscape of possibilities all at once and then just spits out the absolute most efficient physical sequence for the entire yard.
Precisely. It basically dictates the perfect mechanical choreography. And the results speak for themselves.
I'll say.
Pier 300 saw a 60% increase in crane deliveries.
60%. That's huge.
Yeah. They cut truck turnaround times to just 58 minutes. And crucially, they reduced the resource usage of those massive cranes by 40%.
Wow, that is a staggering drop in the energy required to operate the terminal.
It really is.
But having all this brilliant quantum math, evaluating million variable puzzles, it brings up a logistical hurdle, doesn't it?
What do you mean?
Well, it's just numbers on a server.
Mm.
If I am a human port operator managing 7,500 acres of physical land and water, a spreadsheet of quantum probabilities doesn't really help me visualize where a crane actually is.
Right. You can't manage what you can't see, which means you have to clone the port.
And that leads us to this fascinating February 2026 request for proposals that we dug into.
Yes, the RFP.
The Port of Los Angeles is actively soliciting bids to build a digital twin. And from what I read, this isn't just a static map.
No, not at all. They are asking for a living 2D and 3D digital model of the port that integrates all of this real-time spatial and operational data.
The RFP actually outlines 10 distinct capabilities this digital twin must possess. And it's a highly revealing document because it essentially lists every nightmare scenario that keeps a port manager awake at night.
Right, the specificity is just wild.
Yeah. Like capability number 2 is called bathymetry, which is essentially mapping the underwater terrain. They're requiring the ability to visualize sediment accumulation in underwater depth zones in full 3D.
Yes.
Why is that so critical?
Because the vessels crossing the ocean today are becoming unimaginably large. Some of these ultra-large container vessels have drafts. That's the portion of the ship submerged underwater of over 50 feet.
50 feet.
Yeah. And tides change, and underwater sediment shifts constantly, so a static map is totally useless.
I see.
A few feet of unmapped silt accumulation is literally the difference between a ship docking smoothly and a vessel running aground, which would cause a massive environmental disaster and block the channel for weeks.
So the digital twin allows them to compare surveyed depth against target depths in real time just to plan proactive dredging.
Exactly.
And it even integrates this data directly into the portable navigation units used by the port pilots who physically steer these behemoths into the harbor.
Right. It basically makes the invisible hazards visible.
And they want to make the underground hazards visible too. Capability number 3 is mapping substructures.
Oh, this one is huge.
The RFP asks the vendor to consolidate up to 25 layers of underground utilities into an X-ray view of the port.
You're talking about high-voltage electricity lines, industrial gas mains, telecom fiber optics, and just massive water pipes. It's decades of infrastructure buried beneath the concrete.
But if I play devil's advocate for a second here, is building a 3D map of an old water pipe actually going to save money? Or is this just a fancy executive dashboard that looks great in a presentation?
No, it translates to immediate critical safety and financial savings. Let's combine Capability 7 in the RFP, which is capital project mapping, with Capability 10, traffic modeling.
Okay.
Imagine you are a contractor hired to dig a trench for a new on-dock rail line. In the past, you'd rely on outdated paper blueprints.
Right, hoping they are accurate.
Yeah. But with the digital twin, you pull up an exact real-time 3D model on a tablet. You instantly see all 25 layers of substructure, ensuring your excavator doesn't strike an industrial gas line.
And what about the traffic modeling part?
While the construction crew is looking at the underground pipes, operations managers use the exact same digital twin to simulate the physical road closure caused by that construction.
Oh, wow.
They can see exactly how rerouting trucks will back up traffic at the terminal gates before anyone even pours an ounce of concrete.
So it acts as a dynamic GPS for the entire operation.
Exactly. It breaks down the silos between engineering, daily operations, and emergency response because everyone is looking at the exact same authoritative real-time reality.
But creating that real-time reality introduces a terrifying vulnerability, doesn't it? I mean, if you map every single underground pipe, every crane, and every underwater channel and put it on a cloud-based network, you have just drafted a perfect blueprint for hackers.
Which brings us to the dark side of this digital transformation.
Executive Director Soroka actually shared a statistic on this that stopped me in my tracks. Since the pandemic, unauthorized cyber intrusion attempts at the Port of LA average roughly 40 million per month.
Staggering.
And that number recently jumped 50%. 40 million attempts every single month to breach the port's digital walls.
The nature of global threats has completely evolved. We aren't just talking about physical piracy anymore or, a crew stealing a shipping container under the cover of darkness.
Right.
Modern crime and geopolitical warfare have shifted almost entirely to digital disruption.
Because it's so much more effective.
Exactly. If bad actors or state-sponsored hackers can lock down the universal truck appointment system or scramble the quantum crane sequences, they don't need to fire a single shot to cripple the U.S. economy.
So how do you even defend against a relentless siege of 40 million attacks?
Well, the port has actually been remarkably proactive. Back in 2014, they were the first seaport in the nation to establish a dedicated Cybersecurity Operations Center, or CSOC.
Oh, wow.
They were also the first to achieve ISO 27001 certification.
Break that down for me, because ISO 27001 sounds like, I don't know, a random compliance badge.
Right. It is a rigorous international framework for managing data security. It means they aren't just buying off-the-shelf antivirus software.
But it's much deeper than that.
Yeah, they have implemented a continuously audited system of protocols dictating exactly how data is handled, who has access to it, and how they respond the second a breach is detected. It's a culture of security, not just a software patch.
And they expanded on that culture in 2021 by launching the Cyber Resilience Center, or CRC.
Yeah.
This was collaboratively designed with port stakeholders and is actually operated by IBM.
The CRC is fascinating because it functions as an automated early warning system for the entire port ecosystem.
Right. And it's provided free of charge for tenants and cargo handlers.
Yeah, which is key. Say a specific terminal operator gets hit with a sophisticated phishing scam or a piece of malware.
Okay.
Without the CRC, that operator might fight the infection privately while the hackers move on to the next terminal.
But with the CRC?
With the CRC, the IBM system identifies the threat vector and instantly shares those indicators with everyone else in the harbor. It updates the collective firewalls.
So it is a collective real-time defense.
Exactly. And they're taking this globally. The Port of LA co-chairs the Chainport Cyber Resilience Working Group, sharing these strategies with leading maritime ports internationally.
Because securing a port today isn't just about protecting data on a server. If the digital brain goes offline, the physical movement of cargo stops. But that actually brings up the most crucial component of this entire system. We've talked extensively about protecting the digital data and optimizing the machines, but who is actually physically out there moving these boxes?
Oh, yes.
This brings us to the most fiercely debated topic in modern logistics: the human element and physical automation.
It is the unavoidable tension at the center of every port modernization discussion globally.
Now, we are impartially reporting on a recent, extensive January 2024 study conducted by the UCLA Labor Center. It looks specifically at the San Pedro Bay Port Complex.
Right. It was commissioned by the California Workforce Development Board to analyze the impacts of automation.
And currently, the study notes that only 3 of the 12 terminals at the complex use some degree of physical automation, like automated straddle carriers or driverless stacking cranes.
And the findings in the report regarding those automated terminals are super striking.
Yeah, they really are.
The UCLA report synthesizes extensive interviews with industry stakeholders across the board, including terminal operators, supply chain experts, and labor representatives.
Right. And surprisingly, many of these stakeholders heavily question the immediate benefits of physical automation.
That was the biggest surprise in the research for me. You just assume automation equals immediate profit.
Yeah, that's the narrative.
But the report clearly states that globally, there is very little empirical evidence showing that large-scale automated infrastructure yields a positive return on investment. The existing literature does not unequivocally prove that a robot is more productive, safer, or cheaper to operate than conventional equipment driven by human longshoremen.
I mean, the initial capital investment required to rip up a terminal and install automated cranes is astronomical.
Right.
And beyond the lack of proven productivity, the report highlights deep concerns from the workforce. Stakeholders point out that introducing heavy automated machinery alongside human workers creates immediate, unpredictable safety risks.
That makes sense.
Furthermore, managing that machinery leads to heightened workplace surveillance and control over the remaining human workforce. And there is also a profound socioeconomic layer to this that they mention. The report emphasizes fears about local wealth extraction.
Yes, this is a big point.
Historically, the high wages earned by human workers circulate back into the local harbor communities of San Pedro and Wilmington. They buy groceries, they pay mortgages.
Exactly.
The fear is that replacing those jobs with automation takes an engine of local economic stability and exports it purely as profits for international shipping conglomerates headquartered in Europe or Asia.
So the UCLA study isn't just analyzing how fast a metal box moves from a ship to a truck.
Right.
It's evaluating the holistic impact of this technology on the entire human ecosystem surrounding the port.
And the stakeholders interviewed in the report aren't just universally rejecting technology. They champion alternative systemic solutions to maximize productivity without mitigating job loss.
What kind of alternatives?
Well, they suggest increasing the hours of operation to run around the clock, investing heavily in inland ports to ease coastal congestion, creating better worker training programs, and optimizing the existing physical infrastructure to achieve standardization across different terminals.
So they are advocating for human-centered optimization rather than simply defaulting to replacing humans with machines.
Which raises a pivotal question, I think. If the data from this rigorous academic study shows so little evidence of a positive return on investment, Why is the push for physical automation still this massive, unstoppable trend across global logistics?
It's a great question.
Why spend billions if it doesn't clearly move boxes faster or cheaper?
Because it exposes a fundamental friction in global logistics.
Uh,
It's the tension between human adaptability and corporate desire for predictability.
okay, unpack that a bit.
On one hand, you have the proven efficiency of a highly skilled human workforce. If a sudden storm hits, or a container is packed improperly and the weight is off, a human crane operator senses it and adapts in seconds.
Right, humans are infinitely adaptable in a chaotic physical environment.
Exactly. A machine cannot match that dynamic problem solving. But on the other hand, global shipping conglomerates crave absolute mathematical predictability.
Yeah.
An automated stacking crane might not operate as fast at its peak as a veteran human operator,
Yeah.
but a machine doesn't require shift changes. It doesn't take lunch breaks.
And it doesn't negotiate labor contracts.
Precisely. It offers an uninterrupted, perfectly controllable flow of labor. For multinational corporations planning global supply routes, that perceived predictability on a spreadsheet often outweighs the exorbitant cost and the unproven return on investment.
Wow. So it is the friction between the messy, dynamic reality of human labor and the desire for a perfectly controllable, predictable algorithm.
And how the Port of Los Angeles navigates that specific tension will completely define the next decade of their operations.
Let's pull all of these threads together. We started by looking at the Port of Los Angeles as a cardiovascular system, and exploring their 2026 to 2030 strategic plan reveals that managing this system is an incredibly delicate balancing act.
Yeah, you have the integration of quantum-powered combinatorial optimization and the port optimizer orchestrating the logistics.
And you have the relentless daily necessity of defending that digital brain against 40 million cyber attacks every single month.
Right. Plus, you have the drive for environmental sustainability. They're leveraging the Green Asset Score to reduce emissions and pioneering initiatives like their new Green and Digital Shipping Corridor partnership with Singapore.
And beneath all of that, you have the profound human impacts of physical automation, weighing corporate predictability against the livelihoods of the local harbor workforce.
It is an unimaginably complex ecosystem.
It really is. So the next time you were sitting at home, you click order on a website, and a few days later, that package flawlessly arrives at your front door.
Yeah.
Take a moment to think about what actually made that physical delivery possible.
There's so much going on behind the scenes.
Exactly. Think about the 3D underwater maps, tracking shifting sediment to keep a colossal ship afloat. Think about the quantum AI algorithms flooding a landscape of probabilities to find the perfect sequence for a crane.
Yeah.
And think about the thousands of human workers in the harbor community operating that machinery day and night, adapting to the chaos of the real world.
It is an orchestra of invisible data and tangible physical labor, which actually leads me to a final thought. Something not explicitly answered in any of these strategic plans or RFPs, but heavily implied by the trajectory of all this technology.
Let's hear it.
We talked about building a perfect digital twin of the port, a complete 3D clone mapping every pipe and every vessel.
Right.
And we talked about quantum AI optimizing every single physical movement to perfection to prevent bottlenecks. At what point does that relationship flip?
What do you mean?
At what point does the digital twin stop merely reflecting the physical port and the physical port starts just blindly taking orders from the digital twin?
Oh, wow.
When the algorithm becomes that advanced and the digital clone dictates every movement to prevent that economic heart attack who is really in charge of the global supply chain, the messy, adaptable human body, or the perfectly predictable digital brain.
Wow. That is an absolutely fascinating and slightly unnerving paradigm shift to consider. A digital clone eventually running the real world.
Definitely something to think about.
Something to definitely mull over next time you see a cargo ship on the horizon. Thank you so much for joining us on this deep dive. Keep asking questions, keep looking behind the curtain of how our world works, and stay curious.